So creating index is actually not very difficult. Sorry. There's methods for creating indexes from PHP. We're using one here called ensure index. It is basically a synonym for create index. Create index is a new name. And you can create indexes on single fields, on compound fields, or even on fields that are nested, that are part of nested documents. Right, so I'm trying to do that here, right? Create an index on venue.name. And, sorry. And the number, again, is sort order. All right, so it's a good question. So say we have it's okay, I'm the doctor. I'll regenerate. Sorry, Doctor Who jokes. I can do it. I have the Doctor Who t-shirt. So say we have a document that looks like this. Like we have. I'm just coming up with something silly, right? So now we have an array, right? We have an array of, probably if I do this, you'll see a lot of others. No, only one thing, that's it. So we have an array of elements in the food field, right? So what would happen if I set an index on food? So MongoDB is intelligent enough to actually index every single array element to be part of the index. So by doing it gives you some statistics, right? So it tells you come on, this is getting really annoying. Right. So it's created one index for one document, but the index will have 3 documents in there, or 3 element entries in there. One for meat, one for fish, one for pasta. So it works in a similar way as you can do test.find food.meat, right? This is already a query that worked previously anyway, and this is exactly how indexes work as well. So if you set an index on an array, then each of those array elements is going to be part of the index. So you can search on it like that, like I've done before. You find this document. Make sense? Right, so let's have a bit of a look at the compound index. I know this is a slightly different data set again, but I don't think that matters very much. So we create an index on country code and population. So this is a collection that has cities in it. It's a collection of cities. It has country code, population, and the name of it, and it has all lots of other attributes as well. So creating an index on this, you create an index on it. Now, what is kind of interesting, that is of course also explains syntax. If you run the query like this, actually I probably can actually run this. Am I connected to the wrong MongoDB? We get lots of cities, as you can see. I mean, it's, I don't know. Maybe I should only list some attributes because there's too many of them. Let me just do it. Yeah, but it's still not going to be readable, so I'm just doing it like this. See less there. Oh, wrong. Okay. So this way, right? You get then output. Let me turn this off. And turn population on because that's what we're searching on. So you get 3 cities: Glasgow, Birmingham, and the city of London, which is duplicated also as London in my data, in my collection. Broken data. Not even MongoDB can fix, of course. So yeah, you get the answers here. So if you now look at explain, why is this not fitting on the screen? So if I run explain on this, oh yes. Use that, then it gives you actually some output information. It gives a couple of interesting things. The first thing it says, the cursor argument is quite important to see what that tells you. So it tells you it's a B-tree cursor. And a B-tree cursor means it's an index lookup. If it said basic cursor, it basically means full table scan, which you want to avoid as much as you can, of course. And it also tells you which key has been used. So in this case, that is country code _1 _ population _1. The 1 is again is the sort order, but it's part of the key name. And then there is some other interesting things in here. You have those three fields. N stands for the number of documents that have been returned. And scanned objects stands for the amount of index elements that have had to be read in memory or from this. And nscan tells you how many documents had to be read from this. And depending on how good your index is, those numbers don't have to be the same. Now, it also tells you nscanned object all plants. And it basically tells you that MongoDB hasn't tried only one index when trying to do this. It has tried multiple. And we can actually have a look to see which ones they are. Because you can say true, which means verbose, right? And it is and it is really verbose, as you can see. There's lots of data somewhere. So again, the basic information is the same, but then it also says all plants here. So not surprisingly, one of the query plants is the same as the one it picked, which is the B-tree cursor, right? But apparently I also had a different index on here. So I have an index in there on country code, time zone, and ASCII name. ASCII name is the name of the city without all the accents on it. So try that as well. And it tells you that, I think it tried 3 indexes actually. It's also as well. Oop. Sorry, it tried one more here. Did it too fast? Oh yeah, it also tried an index on population and DEM, which is elevation. So it tells you which indexes it had tried, and when you run a query for the first time, without any indexes having been used before, MongoDB will actually try to resolve which index works best by trying all of them at the same time with some clever algorithm. And every time you call explain, it will redo this. So explain always tells you all of the possible keys. If you do that without a true, it will tell you which one has been used as well. Right, so let me go back to the slides. No, it's covered everything in there. Well, the output is slightly different because apparently I had created another index in between making the slide and just running the demo in. So this is important. The cursor should be a B-tree cursor, and those numbers should be, all those numbers should be as closest to the number of documents that you're returning, the closest as to the value that is represented by n. All right, so we didn't sort here, right? So if you don't sort yourself, you get it in index order, which is of course going to be sorted by country code first, population second, because that is how I've set up my index. Now, if you sort it differently yourself by setting a sort option and call explain again, you'll see that another few things changed. You see like the keyword reverse showing up here. And that basically means that the same index has been used, but sorting has happened in the opposite direction, which MongoDB can do. It's just as efficient as sorting in the opposite order or in the order that the index was defined in. So sorting order for indexes with only one column doesn't really make sense to use -1 because it doesn't really matter. This becomes important when you're having compound indexes. So I have a small exercise, we have time for that, which says, so common query with my beers database is to find the 10 highest rated beers ordered by rating score first and graded at second. So I want you to write a script that runs the query with explain, alt the index, run the query again with explain, and then delete the index that you have created. Now, I have not told you how to delete an index, but do you think you can guess how you do that? Yeah, I also thought it was drop index, it's actually delete index. So, there you go. Now you know how to delete an index. Running the query should be simple, because you have done that before. Running the query with explain basically means calling the explain method on the cursor, so that you don't get a result set, but you get a document with the explain output in it. So try this and see what it does. Go. I'm cheating here. Right, so what I actually have done is I created two functions, because otherwise I had to retype it. It's a bit cleaner than copy and pasting. So I created two functions, one that creates a query, which has create a cursor, so we use find, set sort, and set limit, so that I find all the top 10 rated beers. Then we set the limit 10 and return the cursor. So that is running the query. So doQuery is a function that creates a query and then shows the documents. So yeah, we create a query, loop over them, and then output the beer name, the rating score, and when it was created. And as you can see, the created thing is kind of long. So we have to do date create with the value of created at, because that's the MongoDB object that's being returned, and then x is the seconds, so that we can create a PHP datetime object out of it. Way too complicated if you ask me, so on the plane here I've actually written a function that does this for you, so you don't have to bother about that anymore. So this is going to be the new way of doing this instead of this long line. So yeah, we're doing the query, we create a query, and then we call cursor explain. And cursor explain, when you do that, it no longer returns a cursor, but it returns a document or an array with values, which I'm then outputting. So creating the index, I'm using create index. If you have used ensure index, that's fine too. It's the same thing really. So I've created my index, rating score -1, and then created at 1. Have any of you created the index with both directions? So what the indexes that you've created, which fields did they have? Did they have the same fields? Same as the query, yes, that's what you end up doing. And also the same direction as the query, which is important because now we have a compound index, and MongoDB can only do the reverse sort both ways, as long as all the columns are the exact opposite as well. So with this index, we can sort created at rating score descendingly, created at ascendingly, or rating score ascendingly, created at descendingly. It can only do the exact opposite for using the index if you want to do that. And that's quite important. All right, then we create a query again. We call explain because now it should exist after creating the index, and then we delete the index. So when we run this, you get lots of information. So the first time, of course, you get the top 10 beers. And then the explain will say it's a basic cursor, right? As you can see, it actually tries a few times. Mongo 2.6 has a few more index optimization in there, so it tries a little bit more than often just one index. As you can see, this index wasn't really good because it actually didn't return any documents. And of course, we know there's 10 at least, right? So yeah, there's now a special cursor called a query optimizer cursor, which it's basically index intersection. It tries for you to index at the same time before we have created the index, which is kind of strange. Okay, let me scroll through this. Like I said, it's a lot of information. Now, after we've created the index, and we call explain again, you now see that B-tree cursor is being used directly without the basic cursors anywhere involved, right? And that is what you'd like to have. This is by far the best way of doing queries. You can see that n scanned is 11, even though n scanned objects and n is 10. For some reason, it had scanned one more object, one more index, which makes a bit of sense. And I'll show you in a moment how that works as well. And then, yeah, get some more information, and of course, the result is going to be the same, right? So indexes are very important, not if you only have 1,200 documents. If you have 12 million documents, then indexes are important. So yeah, let's have a look at this other compound index. So I have to explain a few more things. So here we have the country code, the name, the population, and the elevation. We create an index, population 1, elevation 1, and then we would like to do a query to find all the cities that are, if I remember correctly, over 1 million people and more than a mile above sea level. So, sorry, larger than 2 million people and above sea level. So what we do as a query, we do population needs to be larger than or equals to 2 million, and the elevation larger than or equals to a mile. That's a mile in meters. And we call explain. So you see that cursor, it says it's a B-tree cursor for population and elevation. So that is the index we expected it to use, because that's the one we created for it. But you also see that n scanned is 131. It's a lot higher than the amount of documents that we've actually been returning. And the cities that you get back are then the following 6. Now, why would n scanned be so much higher? N scanned is the amount of index elements that have been searched on doing the query. Why would this be so much higher? So yeah, it basically can only use the index efficiently for the first part of this query. Because this is the first part of your key, meaning that finding all the cities over 2 million is simple because it can just jump to that position in the index. But for the second one, the elevation, it needs to check all cities that are over 2 million individually, whether it is over a mile high. It's not using the index for the second part. But it also sort of does, because it does still use it for sorting. Just not for finding this element. Luckily, you can see that the amount of documents that are being read is the same as the documents that are being returned, which is still pretty good. It's just a means that the index has been used more than in previous examples. So basically how this works is the following, right? So if we have this index and consider this being the values in the index. We have the name, which is not part of the index, but just showing that as an example here. So the index is on first on population and secondly on elevation. There's actually in the index that I found, there's actually no 2 cities with the same population, except for null, and those were errors. So for MongoDB to do a lookup on this index, what it will do is jump to the position right in the index where the population is larger than 2 million, which is, in this case, Almaty. There's 2,009,000 people. So that is the first thing that happens. And then, it cannot really use the index for the second bit, right? Because it just needs to evaluate all of them. And this is why all those key elements of all the cities larger than 2 million people have to be read, and apparently there's 131 of those. So it then starts looping through this. So the first thing is nscan being 1, because that's Almaty, but it's not high enough, because it's only 793 meters. Then we do Zhengzhou. I'm not going to try to pronounce that name. We have Kowloon, and then we have Johannesburg, and Johannesburg is a city more than a mile above sea level. And at that moment, we have scanned 5 index elements, and we have found 1 document to return. If the elevation wasn't part of the index, that means that MongoDB would have had to read all the documents as well. So even though the index isn't very efficient for the second column, without it being there, it would have been way worse, because for every city it looks at, it would have to pull the whole document with all of its information out of it. Whereas here, it would only have to look at all the index elements. So this is an improvement, but not as good as a single lookup. Does that make sense?
Yeah, you might compare with this middle option. Like
Right. Right. Yeah. So Riches actually works pretty well. Of course, you're better off having a proper index. Okay. So another question from me. Which order of fields would be better now? Would you have in your component index population first or elevation? You want to answer that. Which one would be better?
That totally depends on how many more cities are above the level that I'm searching for.
Yeah.
Higher, basically.
So that is one answer. It depends on the data. If there are more cities over a mile over sea level, then you should have that one last. Yes, you should have that one last and population first, because that means less index elements would have to be scanned. If there are more cities over 2 million people than there are cities over 1 mile, then you need to switch it around that I have here now. But there's another important thing here. The index only works with the amount of distinct values, right? So if there would be lots of cities with the same elevation, then that would make it a less good index. Well, a terrible index, for example, would be having an index on a Boolean value, because it's either yes or no, which is a terrible, terrible index because the cardinality is very low. In most cases, actually seeing that have an index on a Boolean value is just a waste of time, because it just doesn't help you. I mean, you end up reading half of the documents anyway, which isn't a whole lot slower than reading all of the documents most of the time, with exceptions, of course. So that is another thing to look at. What makes sense? What does have the most distinct values, which is the one you tend to be putting first. All right, a few other things that I'll look at is doing sorting the other direction, right? I've already mentioned that the compound key was population ascending and elevation ascending as well. But what if we want to sort elevation descendingly, which we're doing here? So you see that the same index is still used. Nscan is now 127. I guess I did that with a slightly older variant of the collection. But it also says scan and order equals true. And scan and order means that we use the index for looking up the documents, but we cannot use the index for sorting. We cannot use the index for sorting because one of the fields of the compound index goes the wrong direction. Scan and order is something you should avoid, because it means that sorting needs to happen in memory and can't be read directly from the index, which makes it slower. And there's also some internal limitations, like there's a certain amount of memory that is allowed to be used for this kind of operations. And if you go over that, MongoDB says, no, you can't do this. So something to be aware of that, yeah. Scan and order. So remembering that our key was population elevation. So what happens if we just do querying by just the elevation? If you do that, you'll see that no index is being used. Because that makes sense, because indexes can only be used from left to right. Again, just like a MySQL does that. All right, so MongoDB uses indexes in order from left to right. Now, so what happens if we just create another index, right? So we create an index that is also an index on elevation sorted descendingly. And then when we do the sort, you'll see that the elevation -1 sorted descendingly. And you still see that the full key is used for this. You see that population and elevation is being used. Scan and order is still true as well. Anybody wants to guess why this is? Okay, 1 point for you. You can only use one index at the same time. At the moment, in MongoDB 2.6, this isn't quite true anymore because we do support index intersections, but it's in very limited cases. And unless you hit that specific case, this is still very much true. There's also another exception, is that if you have an OR query, for each part of your OR query, it can use an index, because it basically means it's running 2 queries. So if you do find all the documents where the elevation is over 2 million, or all the cities where the elevation is over, no, I'm making a very bad example here. Find me all the cities that are either over 2 million in population or higher than a mile over sea level, and you'd have an index on both elevation and population. And for each of those 2 parts in the OR query, it will use an index, and doesn't have to use the same index. Does that make sense? All right. So indexes, MongoDB uses B trees for indexes at the moment. We are hopefully extending it so that you can have index plugins. There are a few other indexes available, so we have a full text search index, which is not a B-tree cursor. And there's also a geospatial index that I haven't touched at all yet, but allows you to find documents near specific coordinates and stuff like that. But that's another subject I can fill an hour and a half for, which I don't really have. I have another 51 minutes. All right, does it make sense, indexes? All right, so I've mentioned that indexes are used from left to right. All right, so for an index that we have on country code, time zone, and ASCII name, all the 3 queries that I'm showing you now can make full use of the index. It's like country code, because it's the first part of the index, works fine. Country code and time zone works because it's the first 2 of the index. And finding by country code and sorting by time zone also works because that's also the first 2 of your index. Now there's a few where it doesn't work so well. So if you do a find by country code, the first part, an ASCII name, which is the third part, ignoring the second part in the query, then MongoDB will still use the index, but only for the first criteria here. And that's the same thing for sorting. It still uses the index for finding, but for sorting in the end, it will not use the index in this case. It will use a sort and order, or sorry, scan and order. Does that make sense again? Now, there's a few queries that it can actually not use the index for at all. If you only use the second part of the index or the third part of the index, or not using the first part of the index, basically. Also, this should be without the URL. And then there is the last 4 here, where I'm using a find on country code and then doing the sorting on time zone and ASCII name. So there's 2 with a green tick, because the finding is still fine, but it has the sorting in the correct order of the index, right? It's both sorting ascendingly, just like in the index, so it can use the index for that. In the last example, we're sorting both the other direction, meaning that the index can also be used. For the 2 in the middle, the index will only be used for the country code match. Indexes are complicated. So indexes can also not be used in certain other cases, like you do negations, like find me all the documents where this field is not this value. Some arithmetic, like you do modulo searches on fields. If you do a regular expression search, it cannot use the index for that either, unless you anchor that to the start of the string, because it's basically then a prefix string for your index, right? Finding all the documents where a field includes London or Ondo is difficult because the index is like a hash-based lookup, right? Or it's B-tree searching, and it cannot deal with that. So you need to anchor to the start of the string. And like I've done here with London, or with Lon. If you use a JavaScript expression with where clauses, which is something I haven't spoken about yet at all, because you absolutely shouldn't be using that because it's kind of crappy and slow and yeah, just doesn't work very well, so I haven't spoken about it. Or when you're using MapReduce. So MapReduce in MongoDB can also not make use of the index, but the aggregation framework can. So it's not a good reason to use the aggregation framework. Okay, so how does MongoDB pick an index? It does this by just trying them out. The first time you do a query, it will pick up all the indexes and start looping through them. I mean, if they can jump to the correct location first, it will do that. And then step by step, the index that either gets exhausted first or the index that returns 101 documents wins. And this information is cached for, I think it's between 1,000 and 10,000 queries that you do. Unless you call explain, which resets the statistics. And that is going to change in an upcoming version. So, yes, it will retry that once in a while. It remembers the fastest index and things like that. But if you really want, you can also hint indexes. You can say that I want for this query to use this index, which you do with a hint method. And in PHP, you can use, of course, the hint method. That's also first objects. In general, this is not necessary. It's not necessary because MongoDB tends to pick the better index in most cases. So here, as you can see, having the same query as before, the end scan is now 614 instead of the 131 it was before. Right? Yeah, questions?
Perfect. Just one question. When he does not know which index to use, he said he will try every, so in parallel, I guess.
Yes.
So this will, on the first request, and every time he retries or checks if there is something better than this will take more performance from the CPU. Right?
Yeah, it will take a bit more time. This is why there's a limit of this 101 documents to be returned first, because that makes sure that it doesn't do 7 full table scans, for example. Instead, it will just stop after the 100 document it has found. So the first index that yields 100 documents is the one that wins in that case. Because it was the fastest to return 100 documents, yes. Of course, this doesn't necessarily mean it's the best index, but it's likely the better index. This is why sometimes you need to use hints. But in general, you won't have to. Does that make sense? Anything else about indexes? No? Very good. I shall continue with my last subject. So I spent 45 minutes on the indexes, right? Or a little bit. So, which is replication. And replication is quite an interesting feature because it's extremely simple to use, in my opinion. And if we have some time left, we're actually going to set up a replicated environment between a few of us. If you want to participate in that experiment, that'd be fun. All right. So replication is for a few reasons. It is there for high availability. If one node goes down, another one can take over. If you deploy on cloud services, say Amazon AWS, this is not theoretical, it just happens. A bit more frequent than I would like, but it happens. Nodes goes down, network connections break. And you need this. You need high availability. You can also use replications for read scaling. Because there's more copies of your data, applications can read data from multiple nodes. In MongoDB, replication environment, you can only write to the master node. But I'll get back to that in a moment. So replication is also handy for backups. Like you have a production node, a secondary node that can take over instead the primary node fails. And then you have another copy of your data that is used for backups. And you can set up the replication in such a way that this third node is not seen by the PHP driver. So it is solely there for taking backups of it. So from PHP, if you talk to a Replicaset environment, you specify one or more hosts that make up your environment, and the driver will figure out all the other nodes that belong to the Replicaset. but it won't see things like hidden nodes. You can set nodes as hidden, but you can still connect to those directly without setting up a replicated environment. So what you can do is have 2 nodes running your production environment, and then a 3rd node that your admin staff runs complex queries against that your production environment almost never hits and are really quite a bit harsher on your collections and on your database, without it impacting performance of your production environment, which I think is quite handy. And yeah, I've mentioned all the 4 things now. All right, so features of MongoDB Replicaset. So Replicaset is our term for a replicated environment. And it basically is a cluster of n servers, where n is a number between 1 and 12. At the moment, this is a limitation because of the way how the voting protocol works, on which node is going to be master. We are experimenting with changing this protocol, allowing more servers to be part of a Replicaset environment. But that won't be for the next version, I think. So all the writes always go to the primary node, and reads can be from a primary node, and that is the default that the drivers do. But you can also read from secondary nodes if you want to do that. Only one node can be primary. There's an election protocol that elects the primary. That also means that if the primary goes down, there will be an election, and a new primary is elected. There's automatic failover, meaning that if one of the nodes goes, well, so if your primary node goes down, another one takes over, and if that node comes back up, or the network connections are restored, it also automatically recovers and reads all the updates that have happened while it was down. And this is all automatic. There's no tinkering that you have to do unless things go really bad. Question?
Will this then return server, will that become the primary, or?
It could, but it doesn't have to. So
that depends on if the server that is now primary also fails.
Yes, that is likely the case. So you can set priorities on nodes as well, right? You can set, I prefer this node to be the primary node. So if it goes down, then an other node can take over. But when that node comes back up again, because it has a higher priority, it will trigger an election itself so that it becomes primary again. In most cases, I would advise against doing that, because it means you have another disruption when it comes back online. Because the moment the primary node changes, MongoDB will kill all network connections. Which means that if an application is writing to it, or to your primary node, the network connection breaks. So then the application gets an extra failure case that you need to deal with. So even though you can dedicate certain primary nodes, in most cases you don't want to do this, because it creates more disruption for your application. All right, so let's have a quick look at how the replication actually works. So in this case, we have an environment with 3 nodes, member 1, 2, and 3. And I specifically don't refer to them immediately as primary and secondary nodes, because when you start up an environment, there is no such concept. They don't exist. You also need to have an odd number of nodes. You cannot have, well, you can have an even number of nodes, but it doesn't really help much. The reason why you want to have an odd number of nodes is because because if a replication environment is writable, you need to have more than 50% of your nodes up. Meaning that if you have a 2-node replica set, one node goes down, the other one is not the majority, so it cannot be a primary. Meaning that you can only read from your replica set at that moment. If you have 3 nodes and one goes down, 2 nodes is more than 50%, so then they can elect a new primary node. So the reason for this is that if you have only 2 nodes, your application can see both, but they can't see each other anymore. Then how do you know which one is going to be the primary node? You can never know that, right? And what you don't want to have is 2 primary nodes, because your application might write some data to one node and some other data to the other node, and then when they see each other again, they are then in conflict on which data they see. So this is why you need to have an odd number of nodes, or why MongoDB will only elect the primary node if more than 50% of the node can be seen at that moment. Very important. All right, so if you don't want to have 3 data nodes, you can elect one of the members to be something called an arbiter, which doesn't participate in storing data, but it only participates for voting. And an arbiter is a very light run process, so you don't need a very heavy, big machine that you would need for your data storage. Right? So let's have a look. So the election establishes the primary node, and in this moment there's a replicated environment. We have a primary node which, for every insert, update, and delete that happens, it will replicate this information through something we call an oplog. So it's an operations log, which is it's like a MySQL bin log, but then again, it's not binary, and it's actually a collection that you can read yourself. So you can write non-MongoDB processes also looking at this oplog to replicate data from. Really handy if you want to tie Solar into this mix, for example. All right, so this is replication all happening. Everything works, and then the network daemon comes along and kills your node off, or hard drive fails. Happens as well. And then we have no primary node anymore. It goes down. That means the other two will negotiate a new master. Which one it becomes depends on certain factors. The most important thing being the node that has seen the most updates, because of replication can lag a little bit sometimes, right? You have the data on your primary node, but it hasn't been replicated yet to member 2, but it has been replicated to member 1, meaning that member 1 will have the more up-to-date data, meaning that has to become the primary node. If the gap is more than 10 minutes, then MongoDB gives up and says you need to intervene yourself. And that is probably a good thing, because a 10-minute gap, you mean, yeah, if your application still thinks it can write data and you can't write data for 10 minutes, you're probably going to have a problem and you need to have a look at it as an administrator. So there's a few fail-safes built in. A similar thing will happen if the data on 2 different nodes isn't consistent when recovery happens, and in that case, administrator interference is also required. But those cases are very rare. All right, so we have a new primary node. Member 3 comes back up again, and then it goes into recovery state. And recovery stage means let's get all the latest updates of the data to my node as well. And after this has happened, we have a happy Replicaset environment again. And the applications continue to write. They will now write to member 2 instead of member 3, but that's it. Right, I have to say that when a new master or new primary node is being negotiated, at this moment there's no primary node. And you can only write to a primary node. So there is some time when failover happens that you cannot actually do writes. And your application needs to handle this. You'll get exceptions saying that you can't write, of course. Your application needs to handle this. And it's important enough that your application needs to handle this. I'll just say it once more later, maybe too. All right, so how does the replication work? Every operation is written to an oplog. And an oplog is it's a collection with a fixed size. So you can say, let's dedicate 10% of my disk space for this operations log. But it does mean that you need to have enough space in there that if failover happens and a node needs to recover, that the amount of data in the oplog is large enough for a node to sync back from. If you don't do that, then the node cannot catch up with the master because there's data missing in the operations log, which means it has to do a full resync, which also requires, I think at the moment, administrator interference as well. So you need to make sure that you have enough space in your oplog. And that's something you can quite easily monitor, and there's some tools for that as well. Right, so secondaries will read from the primaries operations log and then apply the updates that I find. And all nodes in the replica set will contain this op log. They will contain the op log of the operations that they have applied. Does that make sense again? So, what do you think that happens if I create an update query? For example, it does update all the documents that are of the beer type cider and add this field to it. Or sorry, increase a number in this field by 5. Like, say that I want to readjust all my ratings for cider down by half a point. If I would do this as a query, in MongoDB itself, it would loop through all of those documents and update this value, right? But in the operations log, it doesn't have the query saying, update all of my documents and subtract half a point. No. In the operations log, there will be set statements for the new value for each of the documents. So if you're updating 200,000 documents, in the operations log will have 200,000 entries setting the new value. The reason for this is that if you're replaying back this op log and something goes wrong, then you cannot simply read back to start back where you are, because if you do that, then you'll end up subtracting half a point again from each document. But if you just set values, then there's no problem, right? Because those values are going to be the same. Yes, correct. Idempotent is what you'll, which is very important for this kind of thing. All right, so how do we set this up? If you are on your local machine, you can just set up multiple MongoDB nodes with different ports, and you have to specify that they're using a specific replica set. And a replica set is just a name. In this case, I call it set A, but it can also be cookies, or elephants, or beer. So, it is important that each of those nodes, if you do it on the same machine, have a different database path, because they cannot share data among those nodes. I will often say that this is something you can only do for trying things out, because if you are starting multiple data nodes on one physical server, then both of those nodes will try to use as much memory as they can, trying to starve out the others. So in general, MongoDB's data nodes have to live on their own server, unless you're playing around with things. So basically, those configurations have to be made to start them up, and then I have a sample mongodb.com file if you want to try this on just your own node, so that they all use the same log file, they use small files, and use the same replica set name. Having this on the config file basically means that I don't need to do replica set A, because it's equivalent. Right. When you do this, then you need to configure the replica set by calling an admin command on the shell. You initialize a replica set with its name, and that name needs to match the one that you have here. And then you configure the members. So you have member 0, which is my local machine on port 13,000. And I will ignore the text for now, because that requires another half-hour of explanation. And then we have another node called ID2, which is my other node, so that at this moment there's now a 2-member replica set. And then the last one is we adding an arbiter with a method and so on. And after you've done this, you have a replica set environment, and it works pretty well. Now, I think what would be fun is to try this out ourselves. This is going to be slightly difficult, because I know all of our virtual appliances have set up NAT for internet, meaning that we need to change that. Does anybody want to participate in this experiment? Any takers? Okay, I can do it with just one person, that's fine. All right, so first thing to do is go out of the Easy Publisher, not caring about that anymore, is shut down MongoDB. Okay, I have 2 volunteers?
Yeah.
Oh, you have a question?
I have a question. How about the logs? Would you recommend storing the logs on the NFS, or do we have too many requests on the logs?
So MongoDB's logs is this diagnostic information which you're happy to store in NFS. Okay. Do not store your data nodes on NFS. Do not store your data on NFS. Do not store your data on NFS.
As usual.
As usual, yes. We have some of our customers do that, and it just does not work. It's the locking, it's the latency, it's the caching, it's just a disaster. Do not store your data on LMS. But your logs are fine. It's not really a problem. All right, so I have a volunteer here. First thing to do is stop MongoDB. Sorry, I'm not sure how I increase the size of this font here. Actually, I know a better way of doing this. I have a shell here after it. So we do stop MongoDB. Ask for the passwords. All right, now, yes. So you can only add members to a replica set if they have no data. So well, either you can delete the databases or I can delete the databases, and I don't care which way. Okay. So where do we find the data is then the question, which is in var. I'm not actually sure where it's stored in the appliance. var lib MongoDB? Yeah, that's where they are. Delete everything besides the log file. Do not delete this one. But you can delete the demo 0ns, 0ns, the log file. The log. So once you're done with deleting the files, the next thing to do is reconfigure the virtual machine. I'll wait until you're done. Just shout at me. Oh yeah, there's a few here. Usually they require my external drive, so they're not accessible. Yeah, those are all vagrant boxes, so that's why there's so many.
Okay.
All right. Done with deleting the data? Yeah. Okay. Now go into a virtual box. And go to your appliance and go to settings. And network. And change attached to, says no NAT, change that to bridge adapter. And click OK. Hopefully I'm not breaking anything with this, but you can always change the back later. No, you don't have to reboot. So what you do have to do though, in your shell, you do ifconfig eth down and up. And if everything is right, oh, do I do the, sorry, it is not eth0, it's eth1 that you need to do. Oh, I did. Yes. Why didn't that work? What is the IP address that you get in ETH1? Oh, or, sorry, I think it might be 0x. Let me try, just try it. Yeah, that takes more time. It needs to release the DHCP. Oh, of course, no. Live demos are always fun. I broke it. Oh, I definitely broke it. Because it doesn't react to anything. Oh, come on. Oh, I know what I broke. I broke the network connection, of course. when you do ifconfig eth0 down, it actually brings the interface down. Of course. That's why you have console access. So I'm not sure why I didn't get the updates. It should have changed this one. I did test this at home. Oh, maybe it's this. I don't know how to use it. Oh, there we go. Yes, sorry. It is sudo if down eth1 and then back up again with sudo if up. And then we should get a new IP address. If we are lucky. Okay, I might give up on this if this doesn't working.
Okay, I'm getting this.
You're getting the same, and I know why we're getting this, because we need to log into a browser to actually log into the wireless network with it now, because it has a different MAC address. And I don't think our virtual appliance has a browser installed, so I'm not actually sure how to fix that now. But yeah, that might work. Oh, really? We had to do it before? Okay, I'm going to give up on that. Let's just pretend this worked perfectly well. I was hoping to be able to show it, but I can't. Oh, that's it. Alrighty. You say it's easy, and you're starting with curl.
Should we open a Wi-Fi on the phone or connect via that?
Yeah, that might work. But then I need... can try. But if you have the curl thing, that might be better. It's a massive thing. It's okay, we do curl. Space. Type with me, by the way. Huh? I had to remember the username and password. Open a different shell? Yeah, just press Alt F2. Should go give you another shell. Yes? Sorry, one more time. Okay. Okay, lowercase or like this? Like this? Ten 0 130. Like this? I'm not getting an IP address at all. I think I'm going to give up on this for now. It works. So what I can show you is actually the oplog itself. And just see what's in there. I will use a slightly larger one. Sorry for having to delete your data, but you can always re-import it. So yes, we do Mongo. So we use local. So the database local. Of course, I stopped it. Yeah, blah, blah, blah. So in this database, we have, I haven't started this with the replication. I wish there was an option to do this. REPL set name, I'm just setting it to set name, it doesn't really matter. Stop and start. Yeah, blah, blah. Okay. Once you've started replication, which I hadn't done yet, then it will create an oplog. So you have now database.oplog.rs. I can do fine in it. Doesn't say much more. There's only a simple notification in there now, right? So what I now need to do is insert some data. So we go to virtual environment again, and we run the PHP scripts. Some time, and now you see all this information in the object, right? I know it looks a bit more complicated, but let me pick out one of them. We'll skip a few and do pretty. So what you now see here is actually, it tells you the timestamp when this happens, some hash, the version, which I don't actually know what it means. It then says the operation is I for insert. It tells you into which collection, and then it tells you the object that has been inserted. So this basically says, insert in tutorial beer this document, right? Which is of course a document that we're trying to insert. Now, if we would update one of the beers, so if we do database.beer, no, that doesn't work, it's a different database. So I'll have to do that in a different script. If we do updates, so we do is new Mongo client, and we do c equals tutorial beer, and then we do an update. We update the beer, this one. Should have done that. Control C is no fun. Beer name. We find this one, and what do? We set the rating to or to 42. Cool number. Of course, what I've now done is type JSON inside PHP as usual. That is not the first time I do that. I do that all the time. We do this. 42. Yeah, I should do, but Alright, so this looks correct, right? Oh, we'll see when we run it. And then when we do the op-block find again, and we do pretty. Of course, I need to do the find correctly, so that I'm only seeing the updates, right? Because that's what I'm interested in. And then you basically see what it does, right? So it has the operation is now update in the collection tutorial.beer, and O2 is the document to update, and because documents have this unique ID, it uses that instead of using the name for finding it. Because this for item potency again, and then it sets the value to rating store 42. So this is when we set the value. Now let's see what happens if I increase the value. Set inc. Do the same thing again. You now see that it doesn't do the inc here, it just do the set of the original number and then 42 out. Now you can write a script that reads the op-block and then pumps the data into Soda. It's pretty cool. I've written an article about that. So come and have a look on my website if you're interested in that. Alrighty. Any questions about replication so far? Well, if you don't have any questions now, then that's about going to be it. Except that I have to mention one thing, which is eventual consistency. This is a very important subject, actually. Because when you write to a primary node, the data is not instantly available on your secondary nodes. Meaning that if your application would read from a secondary node, they might see sometimes old data. Which means that it depends on the application whether it's okay for you to read from secondary nodes or not. If your application is okay with sometimes reading slightly older data, like the previous example that I had was with like comments to a blog post, then by all means tell your queries that reading from secondaries is okay. And you can do this per query. You can select per query whether it reads from the primary, which is the default, or when it's also okay to read from secondary nodes. Or if you use tags that I sort of glanced over, you can actually say, I'm okay to read from the primary node or from secondaries with those specific tags, which allows you to set up quite complex things with where some nodes are faster than other nodes. So if you want to read from secondary nodes, you only really want to read from the fast secondary nodes and not the slightly less able machines that you use for other purposes and things like that. So it's really quite flexible what you do. So a warning is here that secondaries may be out of date, and you need to take care of that. Also, don't store your data on NFS. But that's about what I had to say about replication. Any more questions about anything MongoDB related? No? All right, that's what I had for today. Instead of using 3 hours, I ended up using 4 hours and 18 minutes. It's a bit more. I hope you enjoyed this. I hope you learned a lot. If you have any further questions, feel free to email me with questions. I'm happy to answer them. I'm usually a bit slow answering questions, but I will answer them in the end. If that's it, thank you very much, and I hope you enjoyed this. Thanks. Oh, don't forget to vote, by the way, for the sessions. There is a URL, it's called vote.netgenlabs.com. And this number, MongoDB with PHP, is now too low, so you need to do something about it.